To talk about grid-free programming again. This time we'll talk. This lecture should be lecture 17, right? This time, okay. So we will focus on the new API peer. We will talk about how to program it. Program with it. Last time we talked about how to implement such a new API with the grid-free distributed primitives and some. We also talk about some new ideas. How to encapsulate the peer with some existing. We can reuse some design patterns for such a new advanced API. According to my research and investigation, I believe in grid-free, when you program a new advanced API, only distributed primitives are required. You can use distributed primitives to program any APIs. So that's why grid-free become a self-contained distributed self-contained distributed programming paradigm. And more important, the new API. You can, for this new, when you program with a new API, only the existing distributed design patterns are employed. You don't need to invent any other new design patterns for such a new API. That's the most important issue from my point of view, one of the most important issues. So that's also one of the foundation of one of the three foundation of grid-free. Okay, let's continue to talk about how to program with a new peer, this new API, the peer. If we get a new advanced API, we need to use it. We need to program with it. Okay, so usually, if our new API is available, we need to establish the distributed frameworks based on such a new API, right? So the peer, the most important feature of the peer is that the peer can have the important nature. The peer is scalable. So because of that, we can use peer to establish scalable or large-scale distributed system rather than the system that unscalable. We have already see some examples, right? For example, the TNCS, MCS, in such systems, in such a distributed system, because the server, only unique server is available in such a system, so such system is not scalable. But however, a peer is able to processing some old incoming messages, just like CS server. In addition, the peer is also able to forward those incoming message to other peers or servers if required, if this peer has no sufficient computing resources to deal with or to process incoming messages. So here, I will show the P2P framework to you. P2P framework is a typical distributed architecture or infrastructure that you can establish large-scale distributed system. So it's very popular when you need to design a large-scale distributed system. It's very popular in some cluster enterprise-based system, and more important, even you want to establish large-scale distributed system over the internet-oriented computing environment, the P2P architecture is your choice, although the underlying algorithm, some algorithm is different. That means although the P2P framework has some various types, it doesn't matter. It doesn't mean that we have only unique infrastructure based on the P2P distributed model. There are various distributed framework available. We just for this time, we just show you a very simple one, the simplest one. The simplest one we can call it. Let me open these notes. The simplest one we can call it lightweight. And lightweight distribute peer-to-peer, lightweight messaging peer-to-peer framework based on a single registry server. I think I would like to define the distributed framework I will show you today in such a way. That means that there are various P2P frameworks. We just talk about the simplest one, not the most difficult one on there, because if you want to create a system based on the internet or programming environment, everything is different, though. So maybe that system is heavyweight, not a streaming peer-to-peer framework, right? Based on not a single registry server. There are a lot of registry servers. So the registry server is very complicated. We talked about this issue before, right? In the computing environment of the, for example, for the World Wide Web, how can you define registry server for World Wide Web? I don't think a proper registry server is available. Although we have some service that looks like a registry server, but they cannot complete all the tasks, or they cannot provide sufficient support for the World Wide Web. That another system I'm still working on. Okay, this is a system I want to show you today. Another system maybe is the N-tier framework. If we have time, I will also show you another one. This is the N-tier framework. N-tier is also, I think N-tier system should be only used in the environment of the enterprise-based distributed computing environment. I don't think it can be used in an internet-oriented programming environment, because such a system is stable, and each tier is responsible for one particular business-oriented, enterprise-oriented task. So usually, when we created a system based on the internet computing environment, such an environment is difficult and complicated. There are no clear tiers within such a system. The system is dynamic, and you cannot assign one particular task to one specific tier. I don't think it's a N-tier. So that's why I don't think N-tier system is suitable to the internet-oriented distributed computing environment. Okay, but I think it is useful for the enterprise system. Another a typical instance of n-tier is a 3-tier. So first, I will show you for this time, just to show you a 3-tier architecture that implement based on using grid free. You can see, yeah, but the 3-tier is very popular. One typical instance is a web-based application. Almost all web-based application is based on 3-tier. The browser is the first tier. User can send a request and through click the link and use through the HTTP protocols to interact with the middle tier. The middle tier is usually that is application server or web server. So the web server some business logic is located on the web server or the application server. So user can interact with the web server or the application server. And if the data is required, the web server can interact with the backend or the third tier to retrieve data and generate response for the user. So this 3-tier architecture is a very important popular distributed frameworks that widely used at present. I think most people or most developers are familiar with the 3-tier. So I just want to show example, show you the simplest 3-tier that implement with grid free. In such a system, only 3 nodes, only 3 distributed nodes are available. So I call it the simplest one. For some popular system, it's impossible for a distributed system contains only 3 nodes, right? So maybe in a mature system, in a practical system, the middle tier must be clustered. The back end tier, the third tier, must be also clusters because a lot of data and many users need to access the system, so the workload is heavy. And the client is almost unlimited. It's possible, right? Be a large number of users to access such a system. So each tier contains many distributed nodes. However, we can start from the simplest one, right? So in this class, I will show, if I had time, I will show you how we can implement the latest one, the simplest one. Okay, let us continue from here. Last time we stop here, right? Last time we open some old code. I want to close them. This example I created last time, so we want to close it. We start from here. Oh, all of them. Let's continue work here. Okay, so should be P2P, right? Yeah, it's here. Dispatcher, right? We can take a look at that here. If you forget, I just want to show you again. Last time we opened this one. Okay, this one. This is peer is encapsulated within the singleton class, and two fields are here. One instance is a peer, another instance is a server. So this one we already explained, so we don't need to spend much time on that. But this one is not. Maybe it's not. You are not familiar with this field, and however, you can see. Last time we talked about Although you may this is the first time for you to see such code. However, you can see the overall architecture, the design pattern is not. You shouldn't be familiar with that. It's just a combination, aggregation, a strict aggregation of the distributed primitive patterns. So we do not invent any new APIs, right? We do not invent any new APIs. We do not need. I'm sorry. We do not invent any new design patterns. Although we create a new API, right? Okay. Let us take this one here is a new API. However, when we need to use it, because it's a generic, we need to similar to the sales server or design pattern. No, the server dispatcher is required because inside the peer there is a sales server. Sales server need to process incoming messages concurrently, right? That's why chat server dispatcher is put here. So let us open it. Okay, last time we stop here. When you open such a code, I think you must be very familiar with it because it's the same. That's the design pattern, exactly same as a server dispatcher we see in the previous class for the CS server, right? You can see here, this is a server dispatcher for MNCS, multiple request and multiple notifications should be processed. However, for this case, there are still multiple dispatchers that process incoming notifications. It looks simple because the message is limited. A lot of messages are processed on the register server, rather than the peer. So here only 2 notifications are required. For this one is also called chat servers because chatting is a very typical application to show the framework, right? When I want to show you peer-to-peer framework, and the chatting system is a typical one. So usually I always show a new framework if I create it in chatting. Okay, here there's some registry account management and polling. Polling is not used because this is a peer-to-peer architecture, so polling is not useful. So you can see polling request is not need to be processed here. And more important, the registry servers here. Some registry, the account should be managed by the server in MNCS. However, here some account should be the account management also required. But I combine. I want to in such a system the register server is used as a mechanism to manage the chatting account. Chatting account, right? All the users need to register on the register server as a new account for the chatting system. The register server in addition to the account management, the more important service on the register server is to manage the peer. This is the low-level management. So in such a case, the register server is have 2 important tasks. The first one is to manage the peer on the system level. Another one is manage the chatting account on the application level. Okay, so here, because of that, the peer looks simple, right? Compared with this one is more simple. Only two notifications are required to be processed here. Although it becomes simple, the design pattern is exactly the same as the one on the CS server. Okay. If you are interested, we can still open this slide. That's the same, right? That's almost the same. Let us take a look at this one. Add partner. Add partner, right? We can send a notification because here the design pattern is the same, but the application level stuff is different, right? So this is the application level. All the application, the account management, the chatting sessions management, the chatting message have to depend on the CS server in the framework of MCS. However, here for the within the peer-to-peer architecture, that's different. That's different, right? In this case, the server, the peer just get a notification. That notification is displayed on the screen. That's enough. However, here, because the client cannot interact with each other, they have to send a polling message, polling requests to this MCS to get such a notification. So the add partner notification should be added into the chatting session. So other users, the relevant users, can get such a notification through polling. However, here is not required to do that. The message can display on the distributed node, right? This directly. No polling is required. Okay, let us take a look at another one. This is for chatting, right? The chatting message is sent to the peer, and then the message is displayed directly on the device, on the distributed node of the peer. However, for this case, chatting notification here. All the chatting messages should be kept in the private chatting session again for future polling, right? So the polling will access this code, so the chatting message can be respond to the client. That's the way the user can interact with each other instantly in a MNCS system. However, for this system, it's not necessary, right, to do that. So the messages is displayed on the devices of the peer directly. No polling is required. That's a different. However, you can take a look at what about the design pattern? Design pattern is the same. Only business logic or on the application level code is different, right? That's the key point, key issue. Okay, let us take a look at the message. Whether some different on the messages. This is the message of add partner notification. What about this? Okay, we can open the message from here as well. The messages is exactly the same. Although the message is the package is belong to different package, but the implementation is exactly same, right? Okay. Chat message, chat notification. It should be same. Chat notification. Oh, the design pattern is exactly the same. However, here, the chatting message is a little bit simple, right? It's simple because for this case, there are a lot of because the message is saved to one particular session, and so the most important here difference is here, right? There is session K, because all the chatting message have to be saved on the single server, and all the polling message are sent to the unique server. So the server need to differentiate which those messages based on the session K, and the polling message. Polling request contain the session K to access the relevant new messages. However, here there is no such a single server to keep all the messages, and it's not necessary to do that, because the user can interact with each other directly. So such a system is a decentralized one. Such a system is a decentralized one. Because of that, in a decentralized system, is such a system easy to be managed, right? These users need to just interact with each other directly. There are no necessary to design a complete mechanism to save all the data. All the data is exchanged between the relevant users directly. So, and the session K does not make sense in such case, right? Okay, I think it's easy to understand such a system, such a code, right? So let us. This is almost all the code, right? Other code is not required and not necessary to be explained, right? So it's easy, right? Here it's easy, the same thing. The creator, right? Creator is the same thing. We do not need to make any change on that. And yeah, creator. Let us take a look at the creator. Creator same thing, right? Okay, and chat the same, right? No any change happen on the creator. Okay, that's all the code on the peer. Okay, let us take a look at the register. I don't want to explain the register in detail. I just want to show you the design pattern. You must have already all familiar with all the API, because the register server is implemented with DP only. The primary difference happens only on the application level. No any system level implementation have anything new. That on the distributed level have no anything new. Okay, nothing new on the application on the distributed system level. Okay, let us open it. Three instance. This is one for peer. This is the underlying low level management to manage all the peers, to manage the IP address and the name. It's for chatting. This is for chatting because some account should be managed. The chatting, this is application, higher level management. This one is a chain-made dispatcher. This is used to manage the entire system. The register server need to be closed when the chatting system need to be shut down. So for this case, when a notification is obtained, only one, because our system is still simple, so only one notification is sent here. After got this message, the register server need to be stopped. We have you must have see such a code before, right? Okay, and no anything new here. No anything new. Okay, some requested process here. Register pod request, and let us take a look at this one. Pod number, yeah, IP address is necessary to be registered, such that the user can access those information IP and pod IP address through the peer name, because the peer name is stable, but the IP address update all the way. IP address is dynamic. However, the peer of the name is static. We can find peer name is usually it makes sense, right? It's a natural language. It's represent in natural language, so people can easily to understand and to remember it. And the IP address is dynamic and not easy to be remembered. So we need to access the peer's IP address through to get the IP address from the register server, right? Peer address request, that's the way you can access the register server. There's still some other request. Maybe you can see that the last class IP. I will talk about that in the later classes, because one of the most important content for this class for the grade 3 techniques is to implement a cluster-based system. Clustering programming is one of important topic, most important topic of grade 3. We haven't started yet, right? Unregistered. This is also designed for register for cluster. You can see root. We haven't talked about this concept, right? Okay, just leave here. And the chat request, a chat registry. Here, some registry partner request, right? We have such a request in this case, right? Here, right? Chat registry, chat partner. This is the high level, application level registry, not for managed peer. For on the system level, this message is designed, or this code is designed for chatting, right? For chatting, so application. So the register server here have two. I talked about that before. I have two major tasks. The first one is manage all the peer. The second one is used to manage the upper level application. Okay. Okay. This time. Now it's time for us to show this code, how to run it. Okay. Let us access. Access the remote server. No. Okay. This is my project. Oh, the project is shown here. And I'm sorry, I haven't talked about the computer environment. But I think if you are proficient engineer, and you can set up such an environment by according to your preference, right? That's what I have done here. Maybe next time I talk about the environment, the development environment a little bit. But I'm sorry I haven't talked about that. And I think you can. It's better for us to have a terminal, have a unique system, so we can display our system through multiple terminals. Some students in my class, I saw some students just run system using Eclipse. I don't think it's good. It's difficult because such a system we need to run multiple applications, right? Multiple process. It's not convenient for us to show. It's not easy for us to perform debugging using Eclipse. So usually I just programming within Eclipse. That's more efficient. But when I need to debug, when I need to test my system, I use a remote server to do that. Okay. Okay, I hope I can get some time to explain my programming environment. Okay, when and you can see here the one project name P2P chatting, right? Let us open another terminal here. Okay. Registry. First, when you run a peer-to-peer based system, in most time, you have to start up the strategy server first, since all the peers are required to perform registry for the first time. So if the peer registry server is not started, it's impossible for those peers. For example, there are two peers here. These two peers need to interact with each other through that message. However, if the registry server is not started, it's impossible. It's impossible for them to find its partner's IP address. So the registry server is the first process to be started. Okay, start registry server. Okay, that's no problem. Okay, it's starting. Next. Okay. There are 3 projects. Okay, before I start here, I just want to like you to know the server is here. This is a peer, chatting peer. It's another one. The main means we need to manage such a system. Now the management task is very simple. Just shut down the server. At least when you want to implement practical system, admin is necessary. We need to send administration messages to remote server, right? Remote system to manage such a system. Okay, chat peer starting. You must have seen such interface before. It's a very simple user interface, right? Because the users need to chat with each other, so we just type the name. Its partner AB Labs. The local username is Free. Okay. You can see import registry the peer request. So after this client is started, some interaction happen between the register server and the peer, right? You can see here, right? They interact with each other. Then that means the peer is registered here, and its IP address is this one, and the port number is 8944, and then the menu is displayed here. This local user is named Larry Lives. His partner is Free. Okay, the same thing happened on the register server. But that IP address, the IP address same, but the port number is different. How can we avoid the port number conflicts? That's because of the register server. The register server know each peer's IP address and port number. If the IP port number is conflicts between the port number exist, and the register server can notify the register server and assign the idle port to such a peer. So no conflicts between them. That's very important, because at this time the system is still simple. So I just want to show the demo on a single server, on a single computer. So it's possible for them to get the conflicts on the port number. Okay. Next, when we press 1, some registry service happen again, but this one is this service is for account management, for chatting, not for peer. So because the peer registry already finished, so here when you press the button, make a selection from the options of the menu, that means you start something on the application level, not on the system level. System level management already finished for such a case. Okay, you can see peer chat registry request. Do the same thing here. Okay, next, search. Because its partner already registered, so we can perform retrieve to get the information description for its partner. This side can do that again, right? Same thing happened. That's the same as what I have seen in the MNCS chatting. Add friend. You can see here, when I press the option 3, another user get such a notification instantly, almost without any latency. And for this case, on the register server, no any new messages are received, right? Because all the registers finished, and the users get necessary all the essential information between them. No interaction is required during the procedure when the user chatting with each other, right? Okay. Add partner as well. Okay, you can see the interaction between them happen instantly, almost without latency. Actually, there's some latency, but the latency is compared with the latency between the MNCs when they chat each other. Such a latency is very, very short. right? Very short. Just if the latency exists between them, this latency is equal to the network latency, right? Okay. Start chat. Okay. Tap. Hello. You can see here, same thing happened, right? It's happened when we chat each other. Okay. Instantly. Okay. Something happened instantly. We can see a sequence of string X, Y, a sequence of Y, Z, okay, Z again, no, A, okay, instantly. That's a different from the MCS system. Let's quit. Okay, we finished the demo. The demo is successful. Okay, this system still working. So I want to tell you again, mention that again. So when the peer is shut down, some unregistered information is sent to the register server, right? So all the registered information is removed. Okay, next what I should do is to shut down the register server. Okay, stop. You should select the options 4. You can see some other options. I will discuss other techniques in the later classes. You can see multicasting, something that's very important for us to continue to talk. Okay, the server start down. Okay, that's all. Almost finished this topic for this class. And in the next class, I want to show you the N-tier system. And in the later class, after that, I want to create program something based on the peer-to-peer architecture of framework. And I want to program another system based on the 3-tier framework as well. I will program online directory. So I will not, same as before, I will not make any preparation. I just get some new ideas before this class and program directly online. I want to prove that it's easy to program with grid free, even though the system is complete. Okay, that's all for today. Thank you so much. See you next week.